So most of you are aware of Climate Consultant. Climate Consultant is a great program. The more people look at it, the more we will understand how to use it on our projects. I'm sorry? Yeah. And this is a great program during the early analysis, early design process to evaluate what strategies to go after. And what I'm going to do today is just to show all these different tools, not necessarily spend time on how to use these, because that will take more time. But this would be a tool that could be used in the very beginning of a design process. And then, so once you understand climate and how to use that climate and find out which strategies make more sense for your climate, and the next logical step is to figure out the form and shape of the wood. So there are several software programs available, and there is no one single silver bullet or single software that can span from an entire form analysis to the final energy modeling program analysis capabilities. I mean, there is one that IES that they're touting that it will do it, but it's very cumbersome to this point, so we haven't been really using it to that extent. So Revit 2011, Revit architecture has this form analysis part built into it, so you don't have to go out of Revit to do these analysis today. So that's what I'm going to show you now. So remember on one of our sketches we had an elementary school, an office, and a penitentiary. So I just quickly did that, did a massing for these three type of buildings in Autodesk, or actually, this is Autodesk Vasari, but this information or this analysis is already in Revit Architecture 2011. So this is just a simple 70,000 square feet elementary school. It's a two-story school, just a massing of that. I don't have any definition, as you notice. And then for an office, all I did was just a simple box. And then for a penitentiary, a simple mass like this. So the nice thing about this program is all you have to do is just build a mass. You don't have to provide any more definition to the mass. Everything else is taken care in this energy settings box. Here you go ahead and define what type of building it is, and you have a whole range to choose from. And you define where this building is and what type of, ignore all that stuff. And you don't even have to define what type of mechanical system that your building is going to have. Because between your different form analysis, you can assign the mechanical system to be the same.
Is that the default setting?
Yeah, these are all default settings, and that's the nice thing about it. So you just select the type of project it is, and that sets the default for you.
And this is Autodesk Vasari.
Right, and this is no longer available, but this information or this analysis part is inside of Revit architecture that we already have. So we can all use this as of today. So, and as far as the construction goes, it has some basic construction types. You know, you can't really define what the different type of layers you have, but during the early form analysis part, you don't really know that. You can just think about, do I have a high mass wall or a low mass wall? That's all you need to know. And that's how stripped down it is. So you can assign some of these construction types at a very schematic level. And once you do that, all you have to do is hit Analyze Model. And it's going to run through and analyze the model and give you an energy output which would look similar to this. It's slightly smaller. Okay. Is it readable? Is it too small?
Just zoom in on one.
Okay. So what I've done here, I've just compared all these three different building types side by side on that report. But the important thing to understand here is you are evaluating shape or form, right? So the number of people, 1,991 people, kids in 70,000 square feet, that seems alarming, right? We wouldn't have 1,909 kids. So ignore that part. But for your purposes, you're comparing one of this against another of this with all the same defaults. So the people are the same, heating equipment is the same, lighting is the same. Notice the lighting is 1.2 watts per square feet. Everything is the same. You're just going to test these different building shapes to see what their impact is. So what this program tells us right off the bat is that's our EUI, electricity, EUI, and fuel. It assumes that some gas and some electricity, and so that's our total kBTU EUI. So it gives you that information right off the bat. And then it also gives you a life cycle analysis. I wouldn't look at that number into much, because in order to find out life cycle energy and a life cycle cost, you have to have a very accurate analysis. So please ignore this information. It's just a rough number that's there.
What's missing between, if you have electricity,
Right.
fuel?
The units are different. This is in kWh. So you multiply that by 3.412. And then, here's the nice thing. What Ricky and I went through when it comes to solar systems, based on the square footage of the roof that you have defined in the mass, it automatically gives you the potential, renewable energy potential for the roof that you've defined. It tells you these three different options: low efficiency, medium efficiency, high efficiency panels. We used 230 watts per panel. The low efficient panel could be 150 watts or something, and the high efficiency could be 300 watts. So it just gives you a quick potential on that site, on that building. So this is very, very important, right? Our good tool during the early analysis stages. And you know, we don't like graphs, but these are pretty pictures, so I think you'll like it. And gives you the emissions. This is another interesting item, because if your client is really on emissions and not cost, so right off the bat, based on the shape, this is something that I can rely on, because this is a function of the electricity cost and fuel cost, or fuel consumption. So based on the local zip code. So this is something that I would heavily use if emissions is very important. And an example where that could be important is in more of our California jobs, where they are mandating certain greenhouse gas reductions. So it is important to start looking at the greenhouse gas reductions right from the form standpoint. Okay?